What do you think of when you hear the word organic? Do you think of the baby carrots that you saw in the grocery store the other day, or do you think of something entirely different? When we talk about organic foods, we're saying that they were grown using only natural fertilizers. Now, what does this have to do with chemistry? Well, it turns out that for a long time, chemists have been studying the molecules that make up living things. And for a long time, they called this organic chemistry. To them, organic chemistry was the study of molecules that came from living things and from formerly living things. These molecules included sugars, such as glucose, proteins and the amino acids that make them up, such as glycine, fats, and also hydrocarbons, such as methane, which you know is natural gas, and octane, which is a component of gasoline. Think high-octane gasoline, and you've got octane, which are molecules that came from things that used to be living. At some point, scientists decided that they were going to start making these types of molecules synthetically, so the old definition no longer fit. Organic chemistry could not just be the study of molecules that came from living things, but it needed to be a little bit broader. So the scientists went and looked at the different kinds of molecules that were found in living things and found that what they have in common is that they all contain carbon. This leads us to our new definition of organic chemistry, which is that organic chemistry is the study of molecules that contain carbon. Now, if all of these molecules were like methane and octane and contained only carbon and hydrogen, well, life wouldn't be very exciting. In fact, life probably wouldn't exist, since these molecules mostly sit around interacting with other like molecules unless oxygen and fire come along, in which case they burn and turn into carbon dioxide and water. Since we're not running around as flaming people, this means there must be a little more to the story, and it turns out this is true. While organic chemistry is the study of molecules that contain carbon, they also contain other atoms as well. So organic molecules can contain carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. And all of these atoms come together to make what we call functional groups. Functional groups are groups of atoms that we often find together that have a specific behavior. They're also a really good way to help you recognize different classes of molecules, as different types of molecules contain different functional groups. Now, one way that I like to think of this is it's sort of like you're going to go on an OkCupid date or a Match.com date. You've never met this person before. So you say, well, I need to remember what they look like. So you go and you look at their profile and you say, okay, this person whose name is Chemistry is awesome, has glasses and brown hair, and they're about 5'8". So all of this information gives you some idea of what this person looks like and how you will recognize them. And that is exactly what functional groups do for us when we meet new biological molecules. So as we meet new biological molecules, functional groups can help us to recognize them because each of the different types of biological molecule has a characteristic set of functional groups. So we're going to go and meet the functional groups now. The first functional group we're going to meet is the alcohol or hydroxyl group. Now, looking at the name hydroxyl, you might think, gee, this thing probably contains hydrogen and oxygen. And if that's what you're thinking right now, it turns out that you're right. A hydroxyl group is an oxygen atom that is single bonded to a hydrogen and is also single bonded to a carbon-containing group. A common alcohol that you probably know about is ethanol, which can be used as a cleaner and is the alcohol that is found in alcoholic beverages. So a general picture of an alcohol is that it is some group that contains carbon attached to an oxygen that is single bonded to a hydrogen. And a lot of times, chemists use the shorthand R to talk about something that contains carbon. In some cases, it can be carbon or hydrogen. But in the case of an alcohol, it's always a carbon, because if it was not a carbon-containing group, then this would be water. The next functional group that I'd like to introduce you to is the amine. The simplest amine is called ammonia. It is often found in bathroom cleaners. It has a very simple chemical structure, which is a nitrogen atom that is bonded to 3 hydrogen atoms. It's quite small and quite volatile, and that's why it has a very pungent smell. More generally, amines are a nitrogen atom that is single bonded to 3 different groups that contain either hydrogen or carbon. So in the case of amines, an R group can be either hydrogen or carbon, and it doesn't matter. Amines are found in amino acids and are very important in biological systems because they are basic and they can accept protons from more acidic substances. The next functional group that I'd like to introduce you to is the ether, which is found in sugars. The ether group consists of an oxygen that is single bonded to two different carbon atoms. An example that you might be familiar with is diethyl ether, which was used as an anesthetic for a very long time. So if you've ever seen a movie where someone's going in for surgery and they put a cloth over their face, that contained diethyl ether and was meant to knock them out. A more general version of an ether would be just an oxygen atom with any two carbon-containing groups on either side of it. The next functional group is the carbonyl. A carbonyl is a carbon that is double bonded to an oxygen. A carbonyl-containing molecule that you're already familiar with is acetone, which is found in nail polish remover. Carbonyls are found fairly often in biological systems. A carbonyl-containing functional group is the carboxylic acid. Now when you look at the word carboxylic, you probably see carb, as in carbonyl, and oxyl, as in hydroxyl. And it turns out this is the structure of the carboxylic acid. It consists of a carbon that is double bonded to an oxygen and single bonded to an oxygen that is single bonded to a hydrogen, which we know is a hydroxyl group. So it is a carbon that is both a carbonyl and bonded to a hydroxyl group. And these are found in amino acids and in fatty acids in our bodies. One that you might be familiar with, acetic acid, which is the major component of vinegar, and it's what gives it that lovely pungent smell. The last functional group that I'd like to introduce you to today is the ester. Esters consist of a carbon atom double bonded to an oxygen atom that is single bonded to an oxygen atom that is attached to a carbon atom. So it's sort of like you have a carbonyl where the carbon is also part of an ether. And we call this an ester. Esters are important in biological systems because they are what holds fats together, bonding fatty acids to glycerol to form mono, di, and triglycerides. In addition, esters are one of the things that make fruits smell really nice. We've reached the end of our lesson, and I hope that you've enjoyed learning a little bit about organic chemistry and also meeting some of the different functional groups that we'll be encountering as we meet new molecules.